carry out the z-test statistic. Now step number 2, your non-hypothesis will be the population proportion equal to a particular number. So you should be able to get this number from my question, right? And then the alternative hypothesis could be left-sided, right-sided, or two-sided. Now the test statistic is called the z-test statistic, right? So this one only works when you have a large enough sample size, once again, right? And then in this formula, you can see, you know everything. This is the sample proportion.
Hey, what's up,
This is the
Jason?
non-hypothesized divided, right? It's already given, right?
Hey, I was going to ask you, is it possible to record the class that's going on right now?
The number, and then you can get the value of the z-test statistic. Now, z-test statistic follows a standard normal distribution. And then p-value, once again, could be left-tailed, right-tailed, or two-tailed, depends on the alternative hypothesis.
Well, I can ask for next time, I guess.
You can draw your conclusion based on the p-value. Now, so here is the example.
Okay.
Now,
all right, cool.
For example,
Thank you.
if you carry out a survey, and this is the denominator,
So you have to
and
ask,
this is the
like, ahead of
numerator,
time,
right?
yeah.
So the outcome will be whether people answer yes. Means they are willing to pay higher prices to protect the environment. So the outcome is binary, right? So therefore you are interested in the proportion of people saying yes, right? So that's a typical one population proportion problem. So if the question I ask is, test the hypothesis that no more than 50% of the adults answer yes. So no more than means P has to be strictly less than 0.5. So that's why your alternative hypothesis in this case is left-sided. So I have a particular direction in my question, right? But your non-hypothesis is always P equal to something, right? So then you may ask whether the non-hypothesis is always something like that. The answer is no. Yeah. You can carry out a hypothesis in this way. For example, P less than or equal to 0.5, then it's that's make the things more complicated, right? Because all the test statistics we calculated is based on the non-hypothesis true, which means if P only equal to one particular value, that's the truth, right? We can use that information. Now, if your non-hypothesis is like left-sided already, so you don't know the true value, that makes these things extremely complicated. Yeah. So we want to learn about this for the introductory stats class. But if you are in stats major, you will learn that. Yeah. But in practice, in most of the cases, we do care about one particular number for your non-hypothesis anyway. Yeah. So most of the cases, yes, the non-hypothesis will be P equal to a particular value. So, okay, now if I ask whether the about 40% of the adult Americans answered yes, so I didn't tell you the direction, right? Less or more than, it doesn't matter. So therefore, the alternative hypothesis is two-sided now. So that's how you determine whether you use a one-sided alternative hypothesis or two-sided alternative hypothesis. It depends on how I ask the question. Now, to carry out a one-sample test for population proportion, we talk about this PR test, right? And then this is one way to use it if you use the immediate design. If you provide the denominator, the numerator, and then the non-hypothesized value, and then you have to put the keywords count in, right? From this output, so you have to know, for example, how to ask.
What time so
This one says, based on this many subjects, and then 45% answered yes, right? You know how to get all this information. So that's the sample proposal, right? And then you also get the left confidence interval for sample proposal. And then your non-hypothesis is the sample proportion equal to 40%. And then your alternative hypothesis is two-sided, means it does not equal to 40%. And then based on this, you choose a z-test statistic. And of course, before that, you have to verify the sample size assumption, right? Yeah. And then if that assumption is satisfied, a z-test statistic equal to 3.39 in this case it follows a normal distribution, standard normal distribution with a two-sided p-value equal to 0.007, very small. Therefore, you reject the null hypothesis. Yeah. Then you conclude that the proportion of people answered yes is different from 40%. So you reject the null hypothesis because p-value is less than 0.05. So that's it. So for your final project, some students ask me, because we do have the raw data set right there, right? So you can use the PR test command, right? Did I write something? Okay, so you can use the PR test command. So you have a variable, for example, and then you simply testing whether that one, for example, equal to 0.4 or not. So that's it. So, but it's your data set has to be organized. All the 0, 1, 0, 1 means yes or no has to be in one column. So that's the variable name. And then you test whether this variable equal to 0.4 or not. So you should get the same answer. Okay, now how to compare two sample problems, right? If your outcome is continuous, we want to compare two population means, right? So those are the options we have. Now, if we are dealing with related samples, you should consider paired t-test, right? So it's for paired samples. And then if we are dealing with independent samples, then you should consider two independent sample t-tests with or without the equivariance assumption. But for this class, we only learn mathematical detail about this t-test with equivariance assumption, right? So which means you have to carry out another test for testing this equivariance assumption, right? So you have to follow the step. But for your final project, right? So I asked you to provide the stata syntax. So stata syntax means stata command only. No stata output, right? You don't need to say the entire log file, because log file contains both the command and the output. No, I only need the command part, right? And then for the command part, you actually do not need to describe everything in your report, because your report follows a step for journal articles, right? In your syntax, I see, okay, you check the normality assumption, right? Using, for example, graphs like a box plot, or you use a skewness test. And then you check the equivariance assumption by using a variance ratio test, right? So your command has to be there, right? So I know you follow those steps and then determine which is the appropriate test statistic for that question. But in your report, in the method section, you can simply say, I use a t-test with equivariance assumption. So that's it. But based on the command, you have to follow the step and then determine that's the appropriate test statistic for that question. Okay, and then now for all of these test statistics, we assume data are independent, so random samples, and then normally distributed. Okay, so once again, for small sample sizes, the normality assumption is crucial, is critical, right? However, if you have a large enough sample size, the problem is how large is large enough, right? So the rule of thumb is 30, right? So but that's just a guideline, right? The more skewed your distribution is, the larger the sample size is needed, right? Yeah. So therefore, if you have a large sample size and the distribution is not extremely skewed and there are no extreme outlier, then you should be fine. Yeah. Okay. Now talking about whether you should use a t-test with equal or unequal variance assumption, you have to test whether the two populations have the same standard deviation or not, right? So there are different ways to do that, right? But the best way, of course, you carry out a formal statistical test, right? So this one actually very easy to do, right? If for two sample problem, I introduce the variance ratio test, and you can easily carry this out in Stata. So I'm going to show you an example later, right? And then later when we talk about ANOVA, I also talk about Lewin's test, right? So of course Lewin's test can be used for two sample problem as well, right? But variance ratio test can only be used for testing the variance between two samples. So like if you have more than 2 samples, you should consider that means test. So, and you need to familiar with the t-test command in Stata. And this is a very powerful command. It can be used for 1 sample problem, for 2 sample problem, right? For 2 independent sample problem or paired sample problem. And then they also have the immediate form, right? How to use that. So here is an example, right? So if you want to test the effectiveness of a new fuel additive, okay, and then you run the experiment with 24 cars, and then 12 cars with the fuel treatment and 12 cars without the fuel treatment. So in this case, the outcome of interest is the mileage. So that's a continuous variable. And then the explanatory variable is you have this fuel treatment, right? So that's a categorical variable. So therefore, this is a typical continuous variable versus, in this case, binary variable scenario, right? Understanding the relationship between a continuous variable, which is the mileage of the car, and a binary variable, which is whether you will randomize into the treatment group or not, right? So in this scenario, because cars were randomized into 2 independent groups, so these 2 groups are independent from each other, right? So in that case, you should first look at summary statistic, right? That's always a good practice. You see the sample size in each group, right? What's the mean and standard deviation, and you check for whether there are potential errors, right, or outliers. And then let's verify the normality assumption, right? So for your final project, some people ask me, do I have to solve all the box plot for checking the normality assumption? The answer is no. Yeah. So for journal articles, you do not waste a figure just for testing the normality assumption. So as I said, normality assumption is always there. But as long as you say you have a decent sample size, if the distribution is not seriously skewed, you don't need to pay too much attention to the normality assumption, right? Yeah. So you don't need to waste a graph just to look at the distribution of the data, unless you try to make an important point, right? Yeah. And then you also carry out skewness test, right? And then, so this one, you don't need to describe it in your report, but the syntax should be in the appendix, right? So at least you care about the normality assumption. You did something to verify it. Okay, and then the next step, let's check the equivariance assumption, right? So whether you should choose a t-test with equivariance assumption or without equivariance assumption. So just give me this command, and then you know where to look. So this is the p-value. So if this p-value greater than 0.05, then the equivariance assumption is satisfied. So in this case, yes, the equivariance assumption is satisfied, then you decided to choose a t-test with equivariance assumption. So that's the right statistic to choose. Yeah. Once you choose that test statistic, right? So if I give you an output like that,
if it's one more,
you follow the 5 steps, right? Step 1, define your parameter, right? Now your parameter is the difference in mileage before the 2 groups, right? So that's the variable of interest here. So therefore you see difference. That's the variable of interest. Yeah. And then you kind of the first step you say, oh, you check the normality assumption, the equivariance assumption, right? Those are the assumptions, right? Yeah. And then step number 2, define your null and alternative hypothesis. So your null hypothesis is right here. There is no difference between the 2 groups. The difference equal to 0. Now your alternative hypothesis, if it's 2-sided, it's here. The difference does not equal to 0, right? And then step 3, calculate the value of the t-test statistic. That's the value of the t-test statistic. And with a degree of freedom equal to 22, right? You have report degree of freedom, right? Yeah. And then p-value, step 4. P-value in this case equal to 0.167, and it is greater than 0.05. Therefore, step number 5, your conclusion is we failed to reject the non-hypothesis, right? The data didn't indicate any treatment effect. That's it. Yeah. Question?
I just have a question for the equivariance. When you do our program, you said when it's greater than 0.05, that it's
Okay, so,
Is that fine?
yeah.